In Lesson 12, we're going to be talking about subtracting fractions, except for now we're going to be talking about some bigger amounts, some bigger whole numbers, and mixed fractions. The problem that we're going to be working with today is 7 1/5 minus 4 1/3. I'm going to show you what this problem would look like being solved visually using our rectangular fraction models, and then I'm going to relate it to how it would look numerically so you can see the juxtaposition or the connections between both ways. Here I have 7 1/5 shown, and that is our starting amount when we're doing our subtraction. Now we go to starting in on looking at our equation, and first we're going to start with subtracting that 4. So we're taking away 4. It's kind of like having 7 1/5 piece of cake and you're giving 4 of those away. So what you're left with is 3 1/5. Then we want to look at, we still have this 1 1/3 to take away, but looking down here in what's left in our fractions, we can't necessarily take away 1/3 because this is only showing 1/5. So what we want to do is create that common denominator or like unit so that we can take away that extra 1/3. I've shown here what that 1/3 would look like, and you can definitely tell that those size parts are not the same, so we need to make sure that we make them the same before we do our subtraction. So the way that we talked about that was adding those two lines from our one fraction model and then adding the lines from the other fraction model down here. So now we have similar size parts. Each whole has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 parts. And I know that I'm going to be taking away these blue ones from up here in my 1/5. So I'm just going to start taking them away. So I take 1 and 1, 2, and 3. What I realize here now is that I still have to take away 2 parts, but I don't have any left. So what I do is I'm going to borrow, or I'm going to move over to my next whole and divide that into the 15 parts that I was taking away to make it equal to our other wholes, or equal size parts to what I'm taking away. And then I'm going to continue taking those parts away. So 4 and 5. So what I'm left with after I've taken away that 4 and then that 1/3 is 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 parts out of a 15 part whole. So if I would put them all together, I would have 2 13/15. Now I'm going to show you how that relates to our written method. First, we start by identifying our starting amount, which we had as 7 1/5, and in subtraction it's very important to keep track of that. Second, we want to analyze for our estimate, and we analyze by looking at our whole numbers and performing that operation with those whole numbers. So we have 7 minus 4 is 3. So we're going to be looking for an answer, a reasonable answer that is close to or near 3. So step 2 is we want to subtract our whole from the starting amount. Our starting amount is 7 1/5. And just like we showed in our x's here, we were taking away those 4 boxes. And remembering that we still need to take away that 1/3. So we're performing this action first. which left us with 3 remaining boxes that were full and 1/5 of a box. So our equation, after we've taken away those 4 wholes, is 3 1/5 minus 1/3. Now we want to rename and subtract the fractions. So I have my 3 wholes out front, like I still had over here in my visual, but now I'm going to rename my fractions, 1/5, by multiplying it by 1, but renaming that 1, and subtracting that 1/3. But we need to rename that 1/3 because we have different size parts. And when we add and subtract fractions, we have to have equal size parts. So our conjecture is that we multiply the numerator and the denominator by the denominator of the opposite fraction. So we would rename our 1 as 3/3. And then for 1/3, we would multiply numerator and denominator by the denominator of the opposite fraction, which is 5. So we would rename our 1 as 5/5. Then we would find our equivalent fractions. So we would have 3, and our denominator, new denominator, would be 15. And the size, or how many parts we have, is 1 times 3, which would be 3. Minus, we'd have 15 parts here. And we would have 1 times 5, we would have 5 of those parts. Now you can see that our denominators are equal size parts, but what you'll start to notice is that sometimes what your starting number is, just 3, can we take away 5 parts from 3? And if the answer is no, you may need to borrow from your whole, which is related to our visual over here. Is when we ran out, we had those 5 parts to take away and we only had 3 here, we had to go to our next whole and split that up into 15 parts also. So that's what we're going to do over here. And so what that would look like here is I'm going to take one of those wholes, so I'm going to break that 3 up into 2 plus 1, which is still 3. I've just decomposed it or expanded it. Then, because my denominator is 15, I want this 1 to be in 15 parts. So it would be 15 parts out of a 15-part whole. So this step here is relating to what we were doing with this whole here. So we've had 15 parts out of 15 parts, and we are adding that to our original 3 out of 15 parts. And then we're still taking away that 5 out of 15. And what you'll notice here is that all 3 of the denominators are the same, which means our wholes are equal size parts. So what I want to do is, since this 7 1/5 is my original amount, and I'm keeping my original amount the same, I want to kind of rename my original amount first. So I'm going to do this first. So I would have 18 15ths. And the important thing to remember is that 2 is still here. We don't want to forget to bring our wholes down. And then we would take away that 5 15ths. So this 18 15ths here is related back to how many parts we had in this whole, which was 15, plus those 3 from that 1/5 that we had originally, or that 3/15 that we had. So then I can now do my subtraction. So we have our whole is 2. Our sized parts are 15 per whole. And I had 18, and I take away 5, and I'm left with 13. 18 minus 5. So you'll notice that both ways, 2 and 13/15 and 2 and 13/15 is the same. Then last but not least, after we solved and simplified, we want to relate our answer back up to our estimate, which was 3, and ask ourselves, is it a reasonable answer? And 2, I have 2 wholes, and 13/15 is really close to having a whole nother whole, which would make 3 wholes, so my answer is reasonable.